Hello my dear, welcome to IMS Gate Academy. I am Pragyabrat Tripathi, Faculty Department of Mechanical Engineering. So beta, we already discussed the all the content part of the thermodynamics. Now the final part is the entropy, which is very important. Why? Because in the entropy chapter, the gate questions gives the very high level of priority of the entropy chapter, and there are some basic concept for that which already we will discussed. Okay, now today today's motive class is that we have to discuss about the important problem also and how to balance the entropy balance, right? We already sees that what is the energy balance, okay, and now we see that what is the entropy balance. See my dear, what is the balance? Balance matlab something in is equal to something out plus something change within the system. Like if you are deposit some money into your bank account, after some time you get you withdraw that money and the bank will gives your some interest to you. That interest is known as generation. That interest is known as generation. That will depends upon the performance of that your activities. That means, and before that, entropy, what entropy measure? Entropy measure the extent of irreversibility. That means beta, see, we have an ideal process, that means a reversible process. So but in the nature, all the process are spontaneous process. That means have a certain direction, and all the process have a certain rhythms also. That means they have a certain rhythms. Okay, so so in 99% of the things that we have to we are encountering with the process that is a irreversible process. So there is an ideal process and there is a demarcation between the ideal process and irreversible process. So who are the responsible for that measurement, how to extent of that irreversibility? That means if you measure the extent of irreversibility, that we have dealing with the scale parameter known as entropy. With the help of entropy, we can measure the extent of irreversibility, how the extent is there. That means, as we know that all the spontaneous process are irreversible process, that means a natural process. In spontaneous, that means a natural process occurring in the system. Okay, but we want to compare with this irreversible process. That means now we are comparing. What comparing? This irreversible process to what extent they deviated from the reversible process. That means there is a reversible process and we have an actual process. That actual process, how much the extent, that means how much that are deviated. That means we have to a parameter, we have to design a scale that we will measure the extent of irreversibility, and that scale will measure with the help of entropy. Okay, so irreversible process, to what extent they deviated from the reversible process can be stabilized a quantitative parameter, which denoting the extent of irreversibility. So what is the parameter? We all know that the parameter cyclic integration of dq by t is equal to 0 for the reversible process. And if you take that irreversible, that means cyclic integration of irreversible process, dq by t is less than 0. That means this quantity, that means the quantity dq by t for the cyclic integration is behave as a property when the process is irreversible, and the quantity dq by t for an n cycle doesn't behave as a property. Why? Because if there any quantity which have a cyclic integration and that cyclic integration is 0, that means that quantity behave as a property, and the property is a state variable. That means it identifies the system state condition. So we have to develop this kind of the analysis. Already we will done, okay, in the classes already we will done. Now today we have to focus about only how to balance the entropy of closed system as well as an open system. Like that, in a first law of thermodynamics, we have to balance the energy, the balance of energy with respect to a closed system and balance of energy with respect to open system. And in that first law of thermodynamics, open system behaves a steady flow device and unsteady flow device. Steady flow, 99% of engineering devices are steady flow device. That means what is the change in the parameter? within the control volume with respect to time is 0 at any point of the location within the system. That is, we have as a steady flow. Now, what is the unsteady? Unsteady, that means the property within the control volume with respect to time is changing. That means charging and discharging of a tank, inflation of the tire, you blowing the air inside the balloon. These all are pressure cooker. The pressure rise within the pressure cooker also they have a unsteady process. So these are the unsteady kind of process. Now in the entropy we have also balanced the closed system and open system. But in the GATE syllabus, the entropy balance for unsteady device is not there. Okay, is not there. Only we have to discuss the entropy balance for the closed system and open system. And open system behave as a steady flow. That means turbine, nozzle, compressor, pump, throttling device, like that. Okay. Now, so this is the entropy balance. Entropy balance. So first we think that what is the entropy balance? So what is that? Total entropy entering. My dear, what is the difference between, is there we can say that the conservation of entropy? No. Why? Because energy will conserve, but entropy cannot be conserved. But entropy will conserve only when the reversible process. Why? Because generation is 0. The entropy generation is 0 within the system. In that case, what is the entropy transfer due to the heat and mass is the same as the entropy change of the system. That is called the entropy balance. And conservation of, there is no any term of the conservation of entropy, but there is a very limiting sense if you say that there is a conservation of entropy when the process is reversible. When the process is reversible. That means when conservation of energy will applicable for both reversible and irreversible process, but the conservation of entropy only valid only for the reversible process. That means in the reversible sense, we can say that the conservation of entropy and conservation of energy. That's it. Okay, that's it. That means if you're dealing with the entropy balance, so what amount, that means I will already give the example of bank. So you have Hayatul, you have a money which is deposit in the bank. So the total entropy entering, that means depositing, that means you deposit the money. There is a bank, this is your bank in which you deposit the money, minus after some time you can withdraw some money. So total entropy leaving, plus the bank gives the interest. That interest is known as entropy generation, and that generation, that means what the bank give you interest, that interest with respect to your performance. That means this entropy generation behave as a performance. That means this gives the performance of a system. Okay. Yes, already we'll discuss. Entropy balance is same as a energy balance, but there is no generation within the system for the energy balance. That means energy balance, what is that? Energy cannot be created nor be destroyed. It will convert, but entropy not. Entropy will always created, not destroyed. Always created. So creation always when there is a creation, when there is irreversibility. Now, if there is a reversible process, in that sense, we have the conservation of energy and conservation of entropy. But the same sense, what the energy will balance, how the energy will balance, same approach the entropy will balance. Entropy will balance also. But the extra term is entropy generation. Why? Because there, when the entropy will in and out, the system will generate its entropy. That generation depends upon the process of that within the system. If the process is reversible, there is no generation. If there is a process is irreversible, there must be generation. And that's why the generation is always positive. In the limiting sense, it is 0 for the reversible process. Okay, reversible process. So entropy entering, that means you are deposit the money, minus entropy leaving, that means you withdraw the money, plus the bank will give the interest, that is entropy generation, that equal to the change in the total entropy of the system. That means if you take any system, so if you take the energy in the sense of energy, so energy in minus energy out is equal to change in energy of the system. That is the energy balance. That is the energy balance. What is the entropy balance? Entropy in minus entropy out is not equal to the change in entropy of the system. you must be add this generation. Why? Because this generation is your interest, and that will interest you have too. That means what is the entropy? Total entropy change. That means you can say that, sir, I deposit some money and we withdraw some extra money. Why? Because there must be a generation. That means you entering that money, and that entering of money, you have to add that extra amount giving by the bank. That means entropy entering, you can say that entropy entering plus entropy generation, that is interest, minus entropy leaving, is the total entropy change of the system. That is very important, I'm telling you. Okay, so total entropy entering minus total entropy leaving plus total entropy generated within the system plus change in entropy of the system. That is the total entropy of the system. So, my dear, see like that. Delta E of the system is what? Entropy in minus delta E of the system is what? Energy in minus energy out. Delta S of the system is entropy in minus entropy out plus generation. So, if the generation is 0, at anyhow, hi Sita, how are you? If generation is 0 at anyhow, in that sense, the energy of the system, change in energy of the system is exactly equal to the change in entropy of the system. That means the conservation of energy and conservation of energy behave as a equivalency when there is no any generation. That means in the reversible process. That means very, very limiting case. Hi Sita, how are you? Very limiting case. So this generation is 0. That means the process is reversible. The process is reversible, right? Okay. So what is that? S in minus S out. S in is the net entropy transfer. Very important, I'm telling you. This is a transfer. This is a transfer. And transfer with respect to entropy. With respect to entropy. Thank you. Thank you. Yes, yes. I'm also very good. So transfer of entropy only by heat and mass. Very important. Not work. But if you take a net energy transfer, the net energy transfer is due to the heat, mass and work also. That is the very key feature is there. So the net entropy transfer by heat. So my dear, this statement gives you a very subtle concept, ki sir, due to the work transfer, there is no any entropy transfer. Very important. Due to the work transfer, there is no any entropy transfer related to the work transfer. Only entropy transfer related to heat and mass. Okay. So net entropy transfer by heat and mass plus entropy generation, that is the entropy generation. And mind it, beta, this entropy generation is not a property. That means generation is not a property. It is a path function. That means it depends upon the which type of the process is there. This will not depends upon the process. This will not depends upon the process, but this generation will depends upon the process. That means higher is the higher irreversibility. Higher is the higher irreversibility, more is the more generation. That means generation is the exact parameter which represents the extent of irreversibility. Extent of irreversibility. That means higher is the higher. If there is a two process, in which process there is a generation X and the generation is Y. If Y is greater than X, that means Y have a more irreversibility. That means this gives the process actually reversible and or irreversible. So reversible, in that sense the generation is 0. So more and more from the 0, large and large deviation from the reversible. So generation gives the very accurate parameter which defined the extent of irreversibility. Okay. So this is the entropy generation. Okay. And this is the change in entropy. And this change in entropy for the system. System is how much? How many systems? System has 3. One is the closed system, other is the open system, and third one is the isolated system. My dear, during the system is isolated, very important, I'm telling you, during the process happening within the isolated system. So what is the boundary of the isolated system? The boundary in such a way there is no energy interaction. Mind it, when we are discussing with the entropy, only we are discussing the energy transfer in the form of heat, not work. So we don't bother about the work. So if there is an isolated system, you construct an isolated system, and is there any possibility to transfer a work? But with respect to entropy balance, we can assume that the isolated system. This is very important, I'm telling you. But in the fundamentally, what we know that, sir, entropy is the isolated system is a system where there is no energy interaction. But if you talk about the isolated system, in that isolated system there is an entropy balance only with respect to heat, not with respect to work. Okay, so if there is an isolated system, see beta, if there is an isolated system and in this system there is no heat transfer, obviously no mass transfer, that means this is the closed adiabatic system. So isolated system is what? Closed adiabatic system. So closed system have a nothing, there is a very exaggerated meaning. The exaggerated meaning is closed adiabatic system. If there is a closed adiabatic system, there is no entropy transfer. There is no entropy transfer. That means in that sense, what is the generation is the total entropy of the system. That means in that sense, if you take globally, not locally, if you talk about the globally, the generation, entropy generation is the total entropy change of the system. So entropy generation, when the entropy generation is the total entropy of the system, when we are talking about the globally, and that's why the globally entropy always increase. In the limiting sense, if in the process there is a reversible, in that sense we can say that generation is zero. Okay. Now, so this is your entropy. Now, what is the rate form? That means if you divide that with respect to time, if you divide this equation with respect to time, so this is dot, the rate, now there is a net entropy transfer, now you add rate. So rate of entropy transfer only by heat and mass plus rate of entropy generation within the system plus rate of change of entropy with respect to time. Now, if there is a steady, that means if there is a steady device, so in the case of steady device, there is no any change of the property within the system with respect to time at any location. That's why the entropy change of the system with respect to time 0. That means for the steady device, if we have a steady device, what is the entropy balance? Only entropy transfer by heat and mass plus S generation is equal to 0. Okay. So this is precisely the entropy balance. Okay, this is the entropy balance. Now, if you talk about focus about the entropy. So, my dear, see my dear, this is our system. So, this is our system entropy change. Now, the system entropy change responsible only mass and heat. That means if you want to entropy transfer, which mechanism you have to want entropy transfer? Heat and mass. If there is a mass transfer, there must be entropy transfer. If there is a heat transfer, there must be entropy transfer. But if there is a work transfer, there is no entropy transfer. But if you transfer the energy, the energy will transfer by 3 mechanisms. One is a mass, other is heat, and third one is work. So when we discussing about the entropy transfer, that entropy transfer is only responsible for the mass and heat, no work. That means entropy transfer entropy transfer with respect to work is zero. With respect to work is 0. So what is in? That means entropy into the system minus entropy exit from the system, plus there is a generation, plus total entropy change of the system. Mind it, if the system is isolated, that means universe, in that sense change in the transfer of entropy is 0. Why? Because there is no mass transfer. That means if you take a boundary as a whole globally, if you take a boundary, so in that boundary this act as a surrounding and this act as a system. So surrounding and system will interact to each other by the mass and heat with respect to entropy transfer. That means for the isolated system there is no any meaning of entropy in or entropy out. Why? Because we have to take a surrounding as a boundary in which all the activities within the boundary. So there is no any sense of transfer. So in this sense, entropy generation is for generation, and this is for isolated system, is exactly equal to the change in entropy of the system, and that is your total. And that change in entropy of the system is nothing, is equal to, that means this is your isolated system, is nothing, is equal to change in entropy of the system plus change in entropy of the surrounding. That means surrounding and a system behave as a system known as isolated system. And isolated system is what? Isolated system is what? Is a adiabatic closed system. Batic closed system. This is in the terms of entropy. In terms of entropy. Mind it, in terms of entropy. Okay. Now, so my dear, this is your entropy balance. Now, we have to check this one. So, if we have, now we have to separate for the open system, closed system. So, there is a closed system. So, what is the closed system? You have to model like as. That means this is your cylinder and this is your piston. So, this is your system, and in this system there is no mass transfer. If you take this is our system, there is no mass transfer. Only heat transfer is there. Only heat transfer is there. And this is our surrounding. So, system have a temperature, let's suppose T, let's suppose T, system have a temperature T, and surrounding have a temperature T surrounding. So, T of the system is greater than T surrounding. So, in this case, heat will transfer. Now, my dear, there is a one concept is known as immediate surrounding. What is known by immediate surrounding? That means immediate surrounding is a type of surrounding in which this, due to the transfer of this heat, there may be a change. That means if you take, this is your, why? Because the heat will transfer due to the convection effect. Here, why? Because there is a, must be a medium, such type of fluid air. So, if you draw the temperature profile, so this is your temperature profile. Convection temperature profile. So, this is your temperature T system, this is your temperature T system boundary, and this is your surrounding. So, in this sense, if there is a temperature drop is there, up to that, after that the temperature is constant. After that there is no any temperature effect change. So, when the temperature drop will that means there is a considerable temperature drop from the system to the surrounding to the system. If you take that as a boundary, that boundary temperature is known as surrounding, and that surrounding is known as immediate surrounding. Immediate surrounding. So if you talk about that beta, if you have a entropy balance, we'll just tell you, that means there is a S in due to heat transfer. Due to heat transfer, there is a S entropy exit. There is no any entropy inlet. So Si is 0. S exit is 0. Exit is there, but S exit is due to heat transfer plus entropy generation is equal to delta S of the system. So if you take a cyclic integration, integration Q by T, dq by T, Q by T. So which temperature you have to take? If you want to take a system internally, there must be a system boundary temperature. If you want to take a total, that is your surrounding. That is your surrounding. That means if you take T temperature at this system boundary T, there are two temperatures. So if you take Q by T of the system, so this heat transfer is your, this heat transfer plus generation is equal to delta S. So this delta generation, if you want a generation, so this generation is due to internal. This is due to internal. Now if you want that, if you take a surrounding temperature, so if you take a T by surrounding, so in that sense this generation is total. In that sense this generation is total. So this total generation is internal plus external generation. So accordingly you have to find what is the external generation. Okay. So what is the closed system in the entropy balance? So there is a heat transfer. What is the K denotation? So if this is a system, and the system has a different boundary temperature across which have a different heat transfer. So let's suppose there are different boundary. So let arbitrarily take a K boundary. So if there is a K boundary, over K boundary there is a heat transfer Qk divided by system temperature Tk. So if there is a many heat transfer from through a infinite number of the boundary, so summation of Qk by Tk plus generation is there plus system entropy. And what is the system entropy? S2 minus S1, and this is your kilojoule per kg, and that is not a specific term. This is your entropy. Okay. So entropy change of a closed system, my dear, entropy change of a closed system during a process, and the process is anything, the process is equal to the sum of net entropy transfer, and for the closed system the net entropy transfer only due to the heat, not mass. Okay. So net entropy, so closed system during the process is equal to the sum of net entropy transfer. And what is the net entropy transfer for the closed system? Is due to heat only through the system boundary by heat, and the entropy generation within the system boundary is called the system entropy. This is very important. The entropy change of the closed system, that means delta S of the closed system, is equal to entropy transfer with respect to heat plus entropy generation within the system is called entropy balance for the closed system. Okay, entropy balance for the closed system. Now, so this is all for closed system. This is for the closed system, how to balance the closed system, and this is the concept of immediate surrounding. So this is, what is that? This is your immediate surrounding. What is the immediate surrounding? Over which the temperature change is appreciable. That means the temperature change from the surface of the system boundary to the surrounding is appreciable. After that, there is no any further temperature change. That means the effect of the temperature of the system is no more than that is called the surrounding. And so in the case of the entropy balance, we always take system plus surrounding, and surrounding is immediate surrounding. You cannot take like that. Okay. Now, next is the control volume. This is your entropy balance for the control volume. What is that beta? Control volume. Control volume is that the mass and heat with respect to entropy, okay, with respect to entropy. So we have to mass, we have to entropy transfer due to heat plus mass in, mass exit, entropy generation plus entropy change within the control volume. This is very important. That means this is positive, this is summation. That means there is in, out, in, out, in, out, in, out, and take as that summation total. So net entropy, this is your entropy in. This is your entropy in, net entropy in due to the heat transfer plus net entropy in due to the mass transfer minus net entropy exit by the mass transfer. Why? Because beta, see this one, there is a in is here. If there is a in, so this is a heat transfer in. So in is there. So only in part there is addition. If there is a nothing in, only exit is there, only exit in the form of heat. So here we can take summation of all the masses in minus summation of all the masses exit minus summation of all the heat divided by K. Why? Because in that sense, if there is a heat is out, so heat is exit, this is an exit, so you have to add the heat in the exit term. So in general, this is the heat transfer, this is a net heat transfer, that's it. What is inlet? So in the case of heat transfer, what is the heat transfer? You can add, that means what is the summation of Qk by Tk? Let's suppose this is your Q1 by T1 minus Q2 by T2 plus Q3 by T3. This is all the summation. Add this one plus what is the net entropy transfer due to the mass? That is minus net entropy exit due to the mass plus S generation. This is always there plus change in the entropy of the control volume. Okay. Now, if you take a rate basis, that means divide with the time. So Q by m dot, where the Q dot m dot s dot dCV. Why? Because if you want to the rate basis, dSCV by dt. And if there is a steady device, generally, so this dSCV by dt with respect to time is 0. With respect to time is 0. That means what they says that beta? This says that sir, the rate of entropy change, this is your rate of entropy change within the control volume, this is CV, within the control volume, during the process, okay, is equal to the sum of the rate of entropy transfer through the control volume boundary by heat transfer and the net rate of entropy transfer into the control volume by mass flow and the rate of entropy generation within the boundary of the control volume as a result of irreversibility. So generation is due to the irreversibility. So the extra term will add here if there is an open system. So this is a responsible, this is the demarcation. Why this will added? Why? Because there is a control volume, mass in and exit. This will 0 when there is a closed system. This term, extra term, will 0 when the system is closed. Okay. So this is our control volume. This is our surrounding. This is our control volume. So let's suppose in the control volume, mass is in. So with respect to mass in, there is a entropy. This is the specific. Why? Because we know that the entropy S, specific entropy S is equal to total entropy divided by mass. So if you have taken account the mass, if you multiply any property with respect to mass, so that property is a specific property. So this is your MISI, there is a MESE. So this due to the mass transfer, the entropy is in. Due to the mass exit, the entropy is exit. So this is the net entropy transfer due to the mass plus net entropy transfer due to the heat plus generation due to the irreversibility within the system is equal to change in entropy of the closed system. That is okay. So what is that? dQ by T entropy transfer by heat, entropy transfer by mass plus generation. So this is the entropy transfer by mass, this is the entropy transfer by heat plus generation is equal to total entropy change of the control volume. Okay? Okay now? So this is a closed system. Now take a steady flow process. Why? Because many engineering device have a steady flow device. Okay, many engineering device have steady flow device. And what is the steady flow device? Steady flow device is the device where all the property within the system are not dependent, that means inherent with the time, with respect to time at any location. So let's suppose there is a steady flow device and it will look like beta, this is your turbine, this is not turbine, this is your compressor. Why? Because inlet is more area, exit is less area. So this is your compressor. So this device is like a compressor. This device like a compressor. If there is an inlet here and exit here, so there is a, so inlet is here, inlet is here. At this point there is an inlet and exit is there. So in that sense there is a turbine. So these are the notation of this one. So this is a steady flow. That means the steady flow, the system property. So what is the system property? Energy. Okay. The energy, mass and entropy. So with respect to energy change of a control volume with respect to time is 0. Mass change within the control volume with respect to time is 0. Entropy change with respect to control volume with respect to time is 0. So there is no any entropy change with respect to time, energy change with respect to time and mass change with respect to time. So that is called steady device, and in the many engineering practice we have to do this like that. Okay, so what is that? Steady flow. So in the steady flow we know that, we know that in the steady flow there is no any change with respect to time. So my dear, once you have to find the entropy balance, you have to always apply the rate basis. Why? Because along that rate basis, DMCB, DSCB by dt is 0. Steady flow, that means DSCB by dt is 0. If DSCB by dt is 0, my dear, DSCB by dt is 0. So this term is 0. So what is that? Summation of all heat transfer with respect, all heat transfer plus summation of all mass transfer inlet minus summation of all mass transfer exit is equal to entropy generation is equal to 0. Is equal to 0. So this is your 0. So from that equation, you have to find the entropy generation during the steady flow. Now, steady flow, single stream. What is the single stream? Single stream, that means one inlet, one exit. Single stream, that means one inlet. That means, see beta, this is very important. What is the mass balance? What is the energy balance? And what is the entropy balance? So my dear, if you take about like that, if you talk about, very important, I am telling you. So what is the mass balance? Mass balance, energy balance, entropy balance, and there is a one balance also, exergy balance. So we'll discuss in the next session. So what is the mass balance beta? M inlet dot minus M exit divided is equal to dmCV by dt. What is the energy balance? Energy dot in minus energy dot out is equal to DECV by control volume by dt. What is the entropy balance? Entropy in minus entropy out plus entropy generation is equal to dSCV by dt. This is very clear. So if the steady device, what is the steady device? That means the device with the property within the control volume with respect to time is 0. dECV by dt is equal to 0. dSCV by dt is equal to 0. So what is the mass balance? M dot I is equal to M dot exit. That is called single stream. Single stream. This is called single stream. Okay. What is the energy balance? Energy in is equal to energy out. What is the entropy balance? Entropy in, rate of entropy transfer, rate of entropy plus entropy generation is equal to 0. This is the steady flow device. This is the balance of steady flow device. Okay. This is the balance of steady flow device. So we have to like that. So for the steady flow device, single stream, the mass is common here. So there is a single stream, that means one inlet, one exit. One inlet, one exit. So if there is a one inlet, one exit, you remove this summation. You remove this summation. One inlet, one exit, you remove this summation. So you remove this summation. So if you remove this summation, and there is a Mi is equal to Me, so you have to common it. So Se minus Si minus Qk by T. This is for steady flow single stream. So generally we can use this one. This is frequently used equation. Now more precisely, steady flow, that means dSCV by dt is equal to 0. Single stream, that means M dot I is equal to M dot E is equal to M dot. This is single stream. Adiabatic, that means there is a no heat transfer. So my dear, steady flow, this is 0. This equation is there. Single stream, this equation is there. Now adiabatic, so again adiabatic, this heat transfer is 0. So what is your generation? So if there is any equation you look like that, that means this is what? S generation, this is S generation is equal to M dot, and this is a specific, mind it, SE dot, not dot, SE minus SI, that means entropy exit minus entropy inlet into mass rate. This is a mass transfer, rate of mass transfer is equal to entropy generation. So my dear, sometime in the interview, the interviewer asks you कि S generation is equal to M dot SE minus SI. They are written in front of you in the blank white paper, and they says that under what condition. So you have to remember, must understand it. Sir, this is applicable when the steady flow, single stream and adiabatic device. So this equation is more compact equation. What is the assumption of this equation? This assumption is only for the steady device. And single stream. What is this assumption of this equation? Steady flow. So these three equations have, this is the steady flow, this is steady flow with single stream, this is a steady flow single stream with adiabatic. And in this sense, all the time 2 marks of the question in the GATE examination always come into your examination hall. Always comes at this point. So my dear, this slide is very important. I'm telling you, this slide is very important. Okay. Now, so we have to do this one. Now we have to, so we have already discussed with the energy balance, mass balance, entropy balance. Now we have to solve some very good problem. So what I am solving here, the problem with have a constraint time. There is a very limited time, but what I have chosen the question is already comes in the examination, and along with that one, the same question, the same pattern of the question will be your in the gate paper examination. So there must be some invisible term, but I will discuss you what is that. There is a invisible in the lower, so we will discuss that. What is that, beta? There is a wall. See my dear, this is your wall. That question will solve also in the heat transfer, but in the other aspects. Okay, so this is your wall, and consider that steady. See, this is my dear steady heat transfer through a 5x7. This is a 5x7 meter bricks wall. 5x7 meter bricks wall. So this is your meter. So this is your 5 meter. This is your 7 meter. Let's suppose this is height is 7 meter, not required. Height is 7 meter, and this width is your 5 meter. So the dimension is given. What is the dimension? It is given. This is your 7 and this is your 5 meter. And the thickness of this bricks wall is 30 centimeter. That means the thickness of the wall. It is given. Now, one day, and now there is an experiment will start. What is the experiment? One day, when the temperature of the outside, very important, this temperature of the outside is 0 degree centigrade. Outside the house is maintained. So one day the temperature of the outer door is 0 degree. The house is maintained 27 degree. That means if this is your bricks wall, na beta, if this is your bricks, we'll just tell you. So this is your room. This is your room, and there is outside. Yes, this is outside. So they says that outside temperature is one second. Outside temperature, let's suppose outside temperature is 0 degree centigrade. That means very cold. There is a very cold outside. Okay, and house maintained, you want to comfortable 27 degree. That means you are maintaining the room at a 27 degree centigrade, while because outside is too cold, 0 degree centigrade. Okay, the temperature of the inner and outer surface of the bricks wall, that means this inner temperature, it is given bricks wall. This inner and outer surface of the bricks wall is, this is your 20 degree centigrade, and this is your, I think, 5 degree centigrade. My dear, this is the genuine things. What is that? What is they says that? See my dear, if you look very closely with respect to heat transfer, what is that, beta? See my dear, I just draw the figure. No problem at all. What is that? This is your bricks. Okay. So this is your bricks wall. Great, no problem at all. This is your bricks wall. Now, there is a room. So inside there is a room. This is your room, and this is your surrounding. Now, this is surrounding. Room temperature it is given. How much room temperature? Room temperature it is given 27 degree. That means the room maintaining 27 degree centigrade, and surrounding maintaining 0 degree centigrade. Now my dear, this wall surface inside the room, this wall surface maintaining 20 degree centigrade, obviously, and this will maintain 5 degree centigrade. Now what is this? So my dear, there is a layer of the air. There must be a layer of the air. So that is your layer of the air. So this is your layer of the air. So this is your layer of the air, which is your immediate surrounding. This is your layer of the air. Okay, and there is a layer of outside air. This is a layer of outside air. This is layer of outside air. This is layer of outside air. Okay, beta, this is outside air. Now, my dear, this is the with respect to a heat transfer. This is outside. Now, what is this temperature? This temperature. What is this temperature? This temperature is what? Obviously, sir, this temperature is in 27 degree. Why? Because it is not at the wall. And what is this temperature? 0 degree. No problem. And there is a wall of a temperature 5 degree and there is a wall of a temperature 20 degree. Now, there must be a heat transfer through that. There must be a heat transfer. There must be a heat transfer. Yes or no? There must be a heat transfer. There must be a heat transfer. Okay. The heat transfer will take place. And this heat transfer is steady. That means if you take a bricks as a control volume, bricks as a system, there is no any change in the property within the system. So, my dear, this is very important. Okay. So, heat will transfer from that high temperature to low temperature. Now, what is that? We have to take a system and surrounding. So, beta, this is our system, mind it. Let's suppose this is our system. Initially, let's suppose this is our system. 1 second. Initially, we'll take this is our system. Initially, we'll take this is our system. Initially, we'll take this is our system. Okay. Initially, we'll take this is our system. Bricks, wall, our system. So, this is your system. Okay. System boundary. So, this is our system. System boundary. Okay, this is our system boundary. And if we take surrounding, that means immediate surrounding. So, let's suppose this is our immediate surrounding. Let's suppose this is our immediate surrounding. This is our immediate surrounding. What is that? This is our immediate surrounding. Let's suppose this is our immediate surrounding over which the effect is there. So, this is our immediate surrounding. So, this is your immediate surrounding. Immediate surrounding. Immediate surrounding. Why this? This is very near to the surface of the wall. If you take the temperature, the air will flow like that. Air will flow like that. Air will flow like that. So, if you take here the temperature will drop. So, this is our, see my dear, this is our 27 degree. So, from this 27 near that wall, it will drop. So, this is 27 near the wall, it will drop. This is temperature profile. So, up to that one, that means where the temperature will change, this one. It is visible, na? This one. This, the temperature will drop, that is within that layer is your immediate surrounding. Apart from that one, the temperature never changes. Now, in this case, if this is a 20 degree, if this is a 5 degree, so drop will 5 degree. So, this is a 5 degree, so it will drop like that. It will drop like that. So, this is a 5 degree and this is 0 degree. So, the temperature will drop like that. This will dropping the temperature and this will dropping the temperature. So, the temperature profile, that means temperature will change considerably between the surface of the system to the surrounding called immediate surrounding. The temperature will drop considerably. After that, the temperature is constant. After that, temperature constant. So, we don't take that immediate surrounding. We act as a surrounding. So the isolated system is a system plus immediate surrounding. Over the temperature will appreciable. So, from that point to that point, temperature will drop considerably, and from that point to that point, temperature will drop considerably. Okay. So, this is your temperature profile. So, this temperature, this surrounding, this is your surrounding temperature of inside is how much it is given? 27 degrees centigrade. And this is your wall temperature. This is your wall temperature, T of wall, and this is your inside, and this is given how much? 20 degrees centigrade. And this is your also wall temperature. This is your wall temperature, but outside, how much it is given? 5 degrees centigrade. 5 degrees centigrade. And this is your surrounding temperature. Outside, how much it is given? 0 degrees centigrade. So these are the temperature. These are the temperature. Okay. Now we have to balance. Now we have to find what is the what they are asking that. They are asking that. And what is the amount of heat transfer? 1035 watt will transfer the heat from the inside to outside. Determine the rate of entropy generation in the wall and the rate of total entropy generation associated with the heat transfer. This is very important, I am telling you. A student get confused 80-90% here. What is that, beta? See, determine the rate of entropy generation in the wall and the rate of total entropy generation. So rate of entropy generation of the wall and total generation. So if we take this is our system. So what is the total? When they are asking the total, when they are asking the total entropy generation, total, there must be system as well as surrounding. There must be a system as well as surrounding. This is the total entropy generation associated with the heat transfer. And second question is that entropy generation in the wall. There are two things there. So my dear, they are asking that is generation through the wall rate basis dot, and they are asking that entropy generation wall and this entropy generation total. They are asking. What is the difference between these two? What is the difference between these two? There is a wall. This is your wall and this is your total. So once we calculate the total, in that sense, we have to take internal plus external, known as extended system. Known as extended system. So this is your total. When you consider the total, that means you have to take a system as an extended system. That means the system as a extended system. And what is the extended system? Extended system is system plus surrounding. In that sense, what is the temperature you have to put? Surrounding. In that sense, wall, we have the system is only wall. This is our system. So in that sense, we have to take a temperature of the wall. This is very important, I am telling you. So what they are taking, system plus surrounding is the total. And what they are asking? Wall. So these have two things is there, beta. Thank you, Sandeep. So if we take a system, that means a wall, that means total. Now that means a wall. So this is your nothing. This is your entropy generation internally due to internal reversible. So this is your internal reversible and this is your total reversible. So system plus surrounding. So how much? So you know that S generation total is equal to S generation of the wall plus S generation of the immediate surrounding. That means immediate surrounding. That means surrounding. Okay. So wall is what? Internal. S generation is due to internal. And this is your S generation external surrounding. So this is your X generation external. So that is the total. So internal generation plus external generation combined with the total generation. So once someone asks you what is the external entropy generation, you just subtract from total generation to the entropy generation of internal. So from this equation you have to find what is the entropy generation external. So that entropy generation external is equal to entropy generation total minus entropy generation internal. So this is your due to the why this entropy will generation due to the externally. This entropy generation, very important, I'm telling you, this entropy generation externally due to the flow of air. Due to the flow of air, the air will flow, touch. That means there air is a touching, buoyancy effect, convection effect. There is a buoyancy, there is a convection current is there. So due to that convection current, this entropy generation, external entropy generation, if there is a still fluid, the external entropy generation is 0. This is very important. This is the combined effect between the heat transfer and the thermodynamics. That's why this is a very important concept is there. So what is the extended system? What is the entropy generation total? What is the entropy generation internally? What is the entropy generation to externally? That should have a very crystal clear. Okay. So we have to find the entropy generation of wall. That means you have to find the entropy generation internally. So how to find? So internally we can put the wall temperature. Okay. So we have to do this. That means entropy generation due to the wall. That means wall as a system, we have to find it. We have to find it. Now how to find it? So this is a steady flow. So we entropy balance. Entropy balance. Entropy balance. For which one? For wall. For wall. Entropy generation for wall. What is that? S in minus S exit plus S generation is equal to ds Cv by dt. Now my dear, this is a 0. This is 0. This is 0. Why this is 0? Why? Because steady state. Steady state. This is why 0? Why? Because steady state. Now, what is the entropy? And now there this is the entropy transfer. Here only heat will transfer. That means this is your bricks, and in that bricks there is only heat will transfer. So due to this surface, we have to take, this is our system. We have to take, this is our system. We have to take, this is our system. So this is our system. That means this is our bricks wall as a system. So what is the entropy transfer? The entropy in. So in this one, heat will in at this surface. Here heat will exit from this surface. So if you take, this is our surface, so in this heat will add, so positive. Here exit, so negative. So you can like that. So S in, what is the S in? Q divided by, what is the temperature of this wall? That means this is your T of wall inside. T of wall inside minus, this is Q, T of wall outside plus S generation is equal to 0. S generation is equal to 0. So heat transfer, it is there. So this heat generation is due to the wall. So from here we can find S generation due to the wall. Put all this value, mind it, this inner temperature, what is the inner temperature? This inner temperature is 20 degree. This outer temperature is 5 degree. Must be put in Kelvin, plus 273. Plus 273. Must put in Kelvin. So from here you can find S generation wall, rate of heat generation wall, if you find and put the value, there is 0.919 watt per Kelvin. So this is the entropy generation. That means this is your internal entropy generation. This is your internal entropy generation. And this internal entropy generation is why? Due to the heat transfer. Heat transfer internal. So this is a wall. Now, if you find the total, that means you take extended system. You take a extended system. You take a extended system. So if you take extended system, you put the temperature of T of surrounding. T of surrounding. Same balance, the same entropy balance. Entropy balance for extended system. Extended system. And for the extended system, we have to take S in minus S exit plus S generation is equal to dSCV by dt. Again this is 0. Why? Because steady state. Steady state. So in this sense we have to put Q divided by T of surrounding. T of surrounding inside minus Q of T of surrounding outside plus rate of entropy generation is equal to 0. So from here you can find S generation of total. So from that one you have to calculate S generation of total is 0.341 watt per Kelvin. So this is total entropy generation. Now if you find the entropy generation external, that means this entropy generation, if you have interest, if generation total is equal to S generation internal plus S generation external. So you have to find this S generation external is equal to S generation total minus S generation internal. Put this value, both of this one. If you put this value, this is 0.15 watt per Kelvin. So this is why because air flow. Air flow. So I hope you enjoyed this video and you like this. Okay. Thank you. Bye bye.